Why humans are obsessed with building higher. Have you ever stood beneath a skyscraper, then looked all the way up until your neck started to hurt? At that moment, a simple question usually comes to mind. How is it even possible for humans to build something this tall? Most people see skyscrapers as just another building. But behind every giant tower reaching into the clouds, there is a story of ambition, innovation, engineering, and thousands of people working together for years. Interestingly, humanity's desire to build higher goes back thousands of years. Ancient civilizations built pyramids, massive temples, and towering monuments as symbols of power and achievement. But there was always one major problem. The taller a structure became, the more likely it was to collapse. For centuries, building height was limited by available technology. Walls had to become thicker as buildings grew taller. Eventually, the lower floors would have walls so thick that they wasted a huge amount of space. Imagine a 50-story building where the walls on the ground floor are several meters thick. That would be incredibly inefficient. Everything changed during the Industrial Revolution. Steel became widely available. Elevators were invented and improved. And cities started growing at an unbelievable pace. Land in city centers became extremely expensive. Instead of building outward, engineers started building upward. This was the birth of the modern skyscraper. One of the earliest examples was the completed in the late 19th century. It introduced the revolutionary idea of using a steel frame as the main structural support. That simple concept changed construction forever. From that point on, the race to build taller buildings never stopped. Began filling their skylines with towers that seemed impossible. But the taller a building gets, the more complicated the construction process becomes. And that's exactly what we're about to explore. Because building a skyscraper is much more than stacking steel and concrete. It's one of the greatest engineering achievements in human history. Part 2. Everything starts underground. When people look at a skyscraper, they usually focus on the part they can see. But the most important part is actually hidden underground, before a single steel beam is installed. Engineers need to understand exactly what lies beneath the site. They drill deep into the ground, collect soil samples, study underground water conditions, and analyze layers of rock and sediment. All of this is done to answer one critical question. Can the ground safely support the building's weight? To understand the scale, a large skyscraper can weigh hundreds of thousands or even millions of tons. That enormous weight must be supported for decades, sometimes even centuries. If the foundation is poorly designed, the building could tilt, crack, or in the worst case, collapse. That's why skyscraper foundations are very different from the foundations of ordinary houses. Many projects use gigantic piles driven deep into the earth, sometimes extending dozens of meters below the surface. Their purpose is to reach strong and stable rock layers. In some cities, foundation work can take months before the actual building begins to rise above ground. A fascinating example can be seen in Dubai. Engineers had to create an enormous foundation system capable of supporting one of the tallest structures ever built. Even desert soil presents unique challenges, and every detail must be carefully calculated. Engineers also need to account for earthquakes, ground movement, weather conditions, and long-term settlement. Many modern skyscrapers even contain sensors inside the structure and foundation. These sensors continuously monitor movement and stress. If anything unusual happens, the information is sent directly to monitoring systems. The truth is, the foundation is often one of the most expensive parts of a project, even though nobody sees it after construction is finished. Without a strong foundation, no skyscraper would ever stand safely. Part 3. Building the giant steel skeleton. Once the foundation is complete, the next stage is building the structure itself. This is when the skyscraper finally starts becoming visible. You can think of the steel frame as the skeleton of the building. Just as the human body relies on bones, a skyscraper relies on steel beams and columns. These massive components are manufactured with incredible precision, then transported to the construction site. There, tower cranes begin lifting pieces that can weigh many tons. Every beam must be placed exactly where it belongs. Even a tiny error can create serious problems later. One of the biggest challenges at this stage is wind. As the structure grows taller, wind speeds become much stronger. Engineers must design a building that is both strong and flexible. That might sound surprising. Most people assume skyscrapers are completely rigid, but they aren't. In fact, they are designed to move slightly. This flexibility helps absorb energy from wind and earthquakes. If the structure were too stiff, it could suffer greater damage over time. Some skyscrapers can sway several centimeters during strong winds, yet occupants rarely notice. Concrete also plays a major role. Modern high-strength concrete is far stronger than what was available decades ago. Advances in materials science allow buildings to reach greater heights while using resources more efficiently. Every towering skyscraper is really a combination of steel, concrete, mathematics, and incredibly precise engineering. Part 4. How skyscrapers survive powerful winds. Now imagine a building hundreds of meters tall, standing in the path of powerful storms year after year. How does it remain standing? The answer lies in aerodynamics and structural engineering. Before construction even begins, engineers often test scale models inside wind tunnels. These facilities simulate real-world weather conditions. Researchers study how air flows around the building, how much pressure the structure experiences, and how the design can be improved. This is why skyscrapers are not shaped only for appearance. Their forms often serve a practical purpose. Some taper as they rise. Others include curves or setbacks. These features help reduce wind forces. One of the most fascinating technologies used in skyscrapers is called a tuned mass damper. This is essentially a giant weight placed near the top of a building, sometimes weighing hundreds of tons. When the building moves because of wind, the weight moves in the opposite direction. This reduces vibrations and improves stability. Think of a tightrope walker carrying a balancing pole. The principle is surprisingly similar. Several famous skyscrapers use this technology, and in some cases, visitors can actually see these massive devices. Engineers also rely on advanced computer simulations. These programs can predict how a building will behave before it is ever constructed. This saves money, improves safety, and helps eliminate potential problems early. What's even more interesting is that many innovations developed for skyscrapers eventually benefit other types of buildings as well. Research conducted for super tall towers often improves construction standards around the world. Part 5. The global race toward the sky. As technology advanced, countries began competing to build the tallest structures on Earth. Every new record became a symbol of progress, economic strength, and engineering excellence. A building that completely changed the definition of what was possible. But reaching such extraordinary heights introduces entirely new challenges. Materials must be transported hundreds of meters upward. Elevator systems become more complex. Water must be pumped to extreme heights. And emergency evacuation plans become increasingly important. For example, providing water to the upper floors of a super tall tower requires powerful pumping systems and carefully designed infrastructure. Elevators are equally impressive. Modern high-speed elevators can travel incredibly fast, yet they must remain comfortable and safe for passengers. Every detail is carefully engineered. The race for height has also driven innovation. New construction methods, advanced materials, and smarter design strategies continue to emerge. Interestingly, modern skyscrapers are no longer focused only on height. Sustainability has become a major priority. Today's tallest buildings are expected to be energy efficient, environmentally responsible, and comfortable places to live and work. The future of skyscrapers isn't just about reaching higher. It's about building smarter. Part 6. Secrets most people never hear about. There are many fascinating facts about skyscraper construction that rarely get discussed. One of them is speed. On some projects, an entire floor can be completed in just a few days. This is possible because construction is highly organized. Different teams work simultaneously. While one floor is being poured with concrete, another floor may be receiving electrical systems, and another may already be getting interior finishes. Safety is another huge priority. Large skyscraper projects can involve thousands of workers. Many operate at incredible heights, use heavy machinery, and face dangerous conditions every day. That's why safety training is extremely strict. Another hidden secret is the use of digital technology. Modern projects often rely on detailed three-dimensional building models. Engineers, architects, and contractors can explore the entire structure virtually before construction begins. This helps reduce mistakes and improve efficiency. Many projects also use smart sensors during construction. These sensors track concrete temperature, structural movement, and other important measurements. The information is analyzed in real time, allowing engineers to make faster and better decisions. In the end, building a skyscraper is about far more than creating a tall building. It is an incredible combination of science, technology, planning, and teamwork. When we look at a skyscraper reaching into the sky, we are really looking at the work of thousands of people: engineers, architects, crane operators, construction workers, and material specialists, all working together to transform an idea into reality. And perhaps that is the most amazing thing about skyscrapers. Not their height, but humanity's ability to turn imagination into something truly extraordinary. If you enjoy content like this, make sure to subscribe and hit the like button to support the channel, and share this video with friends who might find it interesting.